prisms and cylinders. And I want to talk about what prisms and cylinders are, partly to talk about why do we do them together? Why do we learn them at the same time? Okay, so a prism, think about a cereal box. That's a prism. Okay. Okay, here we go. We have this is a rectangular prism. Okay, now the whole rectangular part, we name a prism for its base. So if I say a triangular prism, I mean a prism with a triangular base. If I say a hexagonal prism, that would be a prism with a hexagon base. So let's talk about what the base is. I'm going to go ahead and make my cereal box see-through. And we'll come back to the idea of in a rectangular prism, it's a little bit less specific. But base doesn't always have to be on the top and bottom. What the bases are in a prism is they are two identical, congruent, exactly the same, parallel polygons. So in this case, in other words, this rectangle up here and this rectangle down here, we could consider those the bases. They're exactly the same rectangle, okay? So they would have exactly the same area, same shape, same size, and they're parallel to each other. So bases have to be parallel. Now, the thing about a rectangular prism is, I could think the same thing about maybe this side and this side. I could call those my bases instead, and that would still work. Because in a rectangular prism, you've got 3 different sets of walls across from each other. You could say these 2 are my bases, or you could say these 2 are my bases, or you could say these 2 are my bases. So you have different options for what you call your bases in a rectangular prism. Now, it's been a while since I've drawn triangular prisms, so let's see how I can do. Yeah, well, that was not the straightest line. All right. There's a triangular prism, okay? And again, these are my bases, the triangles. I have 2 identical triangles. They're congruent, they're exactly the same, and they're parallel. Notice that every single face, it's not actually called a side, it's called a face, but every single surface, every face besides the bases is always a rectangle in a prism, always. Okay, now it doesn't have to be where the bases are on top and bottom. I could have it, no, I'm not real proportional there. Could have it look like this. That is still a triangular prism, and the bases are still the triangles that are parallel to each other and identical. Okay, so they don't have to be top and bottom. If they don't have to be top and bottom, then another thing to realize is the height doesn't necessarily mean up and down. Height of a prism does not necessarily mean up and down. Now, if your bases are up and down from each other, then you can call that the height. Like, then the height is up and down. But what the height really technically is the distance between the bases. So here, this would be my height. When we talk about the height of a prism, we're basically saying distance between the bases. So the height is the distance between the bases. It does not have to be up and down, because the bases don't have to be left and right. I mean, excuse me, up and top and bottom. The bases are congruent, parallel polygons. Now, if we're not talking about prisms, but instead we're talking about cylinders, okay, then the word polygon doesn't apply, but everything else is the same, basically. You have 2 bases, they are congruent, and they are parallel, and the height is the distance between them. So if you think of a cylinder, really a cylinder is just like a prism where the bases, instead of being polygons, are circles. Okay, circles aren't polygons because circles, polygons, remember, have to have segments as their sides. So cylinders. That's pretty decent. Okay, here's a cylinder. Here are my bases. They don't look congruent, but there are my bases of the cylinder. The bases of a cylinder are always circles. Okay, so cylinder has bases that are circles. So they have to be congruent and they have to be parallel, just like here with the polygons. They still have to be congruent and parallel. And just like with the polygons, they don't have to be top and bottom. They can be side to side or front to back or wherever, however it's set up. And just like the prisms, your height is the distance between your bases. Okay, so we have a note sheet that breaks it down a little bit further than this, but let me just point out, you could use the same formula for all of these. The formula for volume of any of these, cylinders and prisms, is the area of the base, and we use a capital letter to stand for area of the base, times the height. You could use that formula for all of them. It's just in a circle, what's the area of a circle is pi r squared. So we usually write pi r squared here instead. If it's a rectangle, what's the area of a rectangle? Length times width. So we might write length times width instead of capital B. For a triangular prism, we usually just write it like this, and we just say, well, what's the area of a triangle? So it's the area of the base, but remember that your base can be different shapes. And so if your base is one shape versus another shape, you have to know how to find the area of these different shapes to get that capital B. So no matter what type of shape you have, and we could have, let's see if I can do it. Let's see if I can do a decent pentagonal. Not too bad. Pentagonal prism. Hey, it's looking pretty good. Okay, there's a pentagonal prism, meaning the bases are pentagons. Okay, and if I wanted to know the volume of that pentagonal prism, I'd have to figure out how to find the volume, excuse me, not the volume, the area of that pentagon. Because you take the area of whatever the base is and then multiply it times height. Okay, so for a rectangle, like I said, your area of the base is length times width. Okay, so that length times width is the capital B. So you can say, again, for everything on this sheet, you could boil down the formula to just this. You just have to know that the capital B doesn't stand for base. It stands for the area of the base, and that it changes depending on what type of shape you have for the base. Okay, so here we go, rectangular prisms. And some of those would be cubes. If the rectangle has the same length and width, then you have a cube. It's a square, right? Okay, so find the volume of each rectangular prism below. So the volume is the area of the base times the height, which means the length times the width times the height. Because the area, the base, excuse me, the area of a rectangle, my base, is length times width. So there are my bases. And again, if a rectangle one, I thought I already did I not? Okay, I will fix that. For a rectangle, you could have chosen any of the sides across from each other to be the bases. Usually, if we have a top and bottom, we like to choose those just because that's how we think of it. But so length times width is 9 times 17. And then my height is 24. So that's all I got to do. So 9 times 17 times 24 equals 3,672. 3,672. And it's centimeters. For volume, it's centimeters cubed, cubic centimeters. It should be there. I'm seeing it on Google Classroom. It says that I posted it at 8:18 a.m. Oh wait, it's the last page. It's only the last page that's showing up. That's weird. Okay, hang on. I'm sorry. Let me pause and fix that for you. If I can. I hope I can. It's very strange. Only my third page showed up. Okay, so that is the third page of your notes that you're seeing there. But this is folks at home. I see why. It says page 3 only. Yes, I want to overwrite it. Re-uploading here, folks. You can, in the meantime, go ahead and try number 2 while I'm doing this. Nothing, no reason you can't go ahead and do that one. Just like number 1, your base is length times width. Your area of the base is length times width, and then you can do times height. Okay, for folks at home, that should have updated by now, or should be doing it as we speak. Okay, so my volume is the area of the base times the height, and that's area of the base is 10 times 14 times 4.5. And the only reason I'm grouping these in parentheses is just to remind you that that's the capital B for this. Capital B for this is length times width. So it really is still the same equation. So 10 times 14 times 4.5 is 630. So 630 cubic inches. Questions on that one? Go ahead and try number 3. Have some latecomers. Go ahead and make sure I give you credit for being here. Although it looks like maybe the people I thought were coming in late came and went. Let me just make sure I see who's here. Okay, so on this one, and it really, I promise, on a rectangular prism, it doesn't matter which one you call the base. I'm going to call this the base, the 8 by 12. So then I have my volume is area of the base, which is 8 by 12, times the height, which is 39. Keep in mind, there's a property called the associative property that says when I'm multiplying 3 things, it doesn't matter how I group them. There's a multiplication property, associative property, and there's an addition property for associative. That basically says if you want to do 12 times 39 first and then times 8, that's fine. That's why it doesn't matter which one's the base. Okay? So we have 8 times 12 times 39. That gives me 3,744 cubic feet. Questions on any of those? Okay, moving on. All other prisms, we don't really want to say length times width because that's only the area formula for a rectangle. So if we have any other shape as the base, we're just going to use the general capital B to say area of the base. So the capital B stands for area of the base. It really is also the same formula, though, remember, that we just used for rectangles, and it is also the same formula that we will use for cylinders. As long as capital B means area of the base, whatever your base is. Now, all three of these, I want you to notice they're a specific type of base. Is all three of these I meant to make, and this one is not as obvious, but it is as well, right triangles. So not just triangles, but right triangles. Here's why I chose to do right triangles. Right triangles, the triangle area formula, which would be area of the base. If it's a triangle, you have to use triangle area, is 1/2 base times height. But sometimes it's hard to find the height. Sometimes the height's not given to you and you have to find it or something like that. With a right triangle, if you're looking at area of a right triangle, it really, the base and the height can just be the two legs because they are perpendicular to each other. Okay, because the height is always supposed to be perpendicular to the base. So since the legs are perpendicular to each other, then you're just doing 1/2 of the leg times the other leg for any right triangle. So here, my base is a right triangle. The legs of that right triangle are 4.5 and 5. So, sorry, I don't need to write that. I need to write V. Okay, now remember capital B stands for area of the base. So in this case, that's 1/2 times the leg times the other leg. 1/2 base times height. 1/2 base times height means of this triangle for right in there. Now we still have a height of the whole prism. There's my height of the whole prism. That's the H. That's what this H is, the height of the whole prism. So that's times 8. So finding the area of just the triangular base is the 1/2 4.5 times 5. That's the capital B. And then the height of the whole prism is the distance between the bases. That's the 8. So I'm going to do 1/2, which I could easily do as 0.5, times 4.5 times 5 times 8. And I get 90. 90 what? Cubic centimeters. Volume is cubic units. I'm going to go back and circle my answers. Okay, these are also both right triangles. So for their area, we're going to do 1/2 base times height. So my volume is 1/2, and the base and the height are the legs of that right triangle. So I'm just going to do 1/2 legs times leg times the height of the whole prism. So that's 1/2 5 times 3 times, and again, the whole height of the prism is 8. think that gives me 60, is that right? Cool. 60 meters cubed. Go ahead and try this one. Always start by thinking about where your base is and what the base is. You really have to stop and think about what the height is for the whole prism here. It's the distance between the bases. So you have to look at how far apart are those triangles, and that's this distance right here. So that's why this is a 6.
What about that 10?
That 10 is the hypotenuse of the right triangle. Remember that right triangles, Pythagorean theorem, 6 squared plus 8 squared would equal 10 squared. Well, we don't have to use it. Okay, because the area of a right triangle is just length times, base times height. We don't have to use the hypotenuse at all. Yes, ma'am.
Are we going to have problems whether the triangle is a right triangle, or are we going to
The only ones I plan on giving you, and at this point, I'll make sure, like I would, at this point, I'm only planning on right. That's why all 3 of these are right. Okay, but if I will make sure to check on stuff as we determine it as a group, and if any quizzes turn out to have something different on them or tests, we'll go back over those. But still, it would be the area of the triangle. It'll still be 1/2 base times height. It's just that might be a little different. Okay. All right. Last but not least, and it's still capital B times H. It's just that on a cylinder, the area of my base is always pi r squared because it's a circle. Okay, so here it's like your B is pi r squared because that's the area formula for a circle. So that's what this is right here. So it's still capital B times H. We just get a little bit more specific if we already know how to find the area of all my B's, all my bases. Okay, so on number 9, volume is area of the base times the height. So that's pi times 18 squared times 15. So we could do this in exact form. We could leave it in exact form, or we could do it as a decimal. Exact form, that would be 4860 pi. And if I change that to a decimal, that's 15,268, let's say 0.1. And that's cubic inches. You guys know I'm not really good about units. So no, I'm not going to count off if you don't do the units right. If you don't remember to put the units. Okay, what do you have to be careful about on number 10? Bingo. Yes. Does everybody see that? It gives you the diameter and not the radius. So since the formula uses radius, I have to look at this and say, okay, then my radius would be half of 11, which is 5.5. And that's what I'll use. So I've got pi times 5.5 squared. And y'all, if we're already in decimals, we might as well use decimals instead of exact form. We don't usually use decimals with exact form. The height of the whole prism, cylinder is 21. So pi times 5.5 squared times 21. And you notice that the calculator thinks the same thing. It does not try to give you exact form when there's decimals involved. It's about 1995.7 cubic meters. Questions on that one? Okay, I have given you 6 practice problems below here that are just like the 3 different types of problems we just did. So I'm going to give you a few minutes to go ahead and try those 6 practice problems and let you check your answers before we go. Since you just worked with cylinders, you might want to jump to the cylinders. But remember that these are mixed up, so you have to stop and think about which one am I doing? Which type of prism? Is it a right triangle base? Is it a rectangle base? Or is it a circle base? On the circle ones, I'm encourage you to try to do both exact form and decimal form. And you can round to the nearest tenth on the ones that you do decimal form. Give you a couple more minutes. If you are not ready to check your answers, you don't have to look. But if you are, there they are. Any of those you want me to talk about how I set it up? Okay, then last page of your little packet here is the homework. I have not handed it out to people who are in the classroom yet. It's still on the Google Classroom page. It's 8 more problems just like these 6 plus 2 where you have to work backwards. Like you know the volume and you're missing the height or you're missing the length or something like that. So you still use the formula the same way. You would just plug in the V if you know the V and not plug in whatever you don't know and then try to solve that equation. Any last questions on this before I go ahead and call it a day? Okay, today's what, Thursday? So I will see you tomorrow, folks at home. Thanks for coming.